Okay, Vishnu. So I am going to start our chapter number one, and the chapter number one name is the basic concept of the chemistry. Okay, and in this chapter we will going to discuss about the certain laws, and then the main portion here in this chapter we have to discuss about the mole concept. So basic concept of chemistry. Okay. So in this portion, basic concept, I guess you are very well aware about the like how we usually subtract, how we usually like do the addition. So there are many things which you need to take care. Okay, suppose okay, I have you ever heard about the term significant figures? Significant figures.
Yeah,
Okay, okay.
I don't know what it
So,
means though.
okay. So, firstly, in the chemistry, as it is the beginning, so I want to ask you the element. So, all the portion, like in the periodic table, of course, you know it, like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon. All these things are elements only, na? It is the pure
Yeah,
form of the matter, okay, which possess only the
yeah.
same kind of atom. So element is
Hmm.
something, okay, which is the pure form of the matter. If I say sodium, so sodium contains only sodium atoms, na? So if I
Yeah.
am saying I have a element and it's the sodium, so sodium contain only the sodium atoms. So it is the pure form of matter which possess only one type of atom, not the other kind. One type of
Hmm.
one type of atoms. Fine. जैसे
Yeah.
example I can take, suppose sodium I have, suppose I have the beryllium, suppose I have boron. So sodium contains sodium atom, beryllium contain beryllium atoms, boron contain boron atom, nitrogen contain nitrogen atoms only. So all these are the elements only. Okay. And you can also say in other language like metals, non-metals, and the metalloids. Metals have, remember always Vishnu, metals have the tendency to lose the electrons. Non-metals have the tendency to gain the electron. Okay, and metalloids are lying between them. So whenever I say metal, so there is a image in your mind. Okay, you should make the image like metals are very good in losing the electron, and non-metals are very good in gaining the electron. Fine.
Okay.
Okay. Now, if I talk about the compounds, so obviously you know it when two or more elements combine in a fixed ratio. So they
Hmm.
will, it is known as a compound. So it is also a pure form of matter, but the thing is, it is not containing only one, it is containing more than one. So pure form of matter, which consists of two or more element, okay,
Yeah.
which possess two or more elements. Suppose if I
Okay.
say and of course they are combining in a particular ratio, okay, so they are combining in a two or more element in a specific ratio. It is
Yeah.
not the random one. Suppose I have H2O. So just can you just tell me how many elements of hydrogen are there and how many oxygen? You will say, yeah, hydrogen is element, but in the one H2O, two atoms are there, na? Two atoms of
Yeah.
hydrogen and one atom of oxygen. So it is the fixed ratio, 2:1. Hydrogen ratio O, so it is 2:1. You can't take three, you can't take one. So that's why it is the fixed and fixed ratio by mass as well. You have to take care of that. See, one hydrogen has a mass of 1 unit. So it is a two hydrogen, so its mass is 2. And oxygen का mass कितना होता है? What is the mass of oxygen? It is
Six.
16. Okay. So when you just find out the simple ratio, so it will become 1:8. Okay. So it means the mass ratio of H2O is 1:8. So you can't change it, and you just can't make any, you just can't take any other mass for water. You have to take this only. So in a compound, there is a specific ratio. They always combine in a definite proportion. Okay, definite. It is not the random one. But if there is a random one, Vishnu, if you are just putting the things randomly you are just adding, then it will become mixture. Okay. So mixture is something in which there is no specific ratio. You are just adding the things randomly. So it is the impure form of matter, because it is containing things randomly. There is no fixed ratio, and it can contain more than one element as well. Suppose you have a
Okay.
container, you just drop some element randomly. Okay, there is no calculation, and you are just mixing it up. So when you are mixing it up, you are just throwing the things randomly. So obviously there is no definite ratio, na? So you will call it as a mixture. Even you don't know how much amount you have just put inside that vessel. So obviously, so it is an impure form of matter, and it contains different elements in any ratio. I don't know even the different elements. Fine, everybody. I mean Vishnu. So
Yeah.
you should know a mixture can be of two type. Okay, homogeneous and the heterogeneous. Homogeneous means which
Yes, that
have a
makes sense.
uniform composition. Suppose Vishnu, if in a glass of water you had just put a one spoon of salt, one spoon of salt, okay, and you are
Mhm.
just mixing it. So just tell me that salt will completely dissolve in water, or it is like downward side, it is more soluble. It is uniformly mixed, or it is
I think it'll completely dissolve.
yeah, it is completely mixed, na? Like you will get the same taste at the upper layer, at the middle layer, and the downward layer. Because salt can easily adjust, salt can easily dissolve. So it is a
Hey,
homogeneous mixture. So homogeneous
right.
mixture means which have a uniform
Uniform.
composition. Yeah, uniformly mixed. But just tell me, if you have a soil and you just put a soil into the water, so will it uniformly mixed?
No.
No, soil will settle down, na? So,
Saga.
so it is going to be settled down. So heterogeneous. Okay. So it is a non-uniformly mixed. So you will say it's a non-uniform composition. Fine. So non-uniform
Yes,
composition
and
means it is not going to be dissolved equally. It is unequal one. Okay. Okay. So I want to ask one thing. Suppose Vishnu, if I am adding chalk powder in the water, so it is homogeneous or the
what?
heterogeneous? Chalk powder into water.
What powder?
Chalk powder, chalk.
Okay.
We write in a blackboard, na? So that chalk. I just make a
That might
powder.
settle down. Settle-
Yeah, so it will settle down. So it means it is homogeneous or the heterogeneous.
hetero.
Yeah, it is heterogeneous because it is not going to be mixed uniformly. It is going to be settled down. So yes, fine.
Yeah.
So mixture is of two type.
Yes, sir.
And just tell me, mixture is a pure form or impure form?
Pure form. No, no, impure. Impure. Its mixture is impure, but compound
Yeah,
is pure.
yeah. Compound is pure. Mixture means randomly. Okay.
Yeah.
Mixture means you
Yeah.
are putting things randomly, different element.
Yeah.
Even you don't know how much amount you have just put. Okay, you are just putting
Yeah.
randomly. So it is mixture. So yeah, one question here I want to ask, what is the main difference between the compounds and the mixture? So you will say whenever there is a fixed ratio of mass of the elements and they are combining it to form compound. But when there is no fixed ratio, they are just combining randomly, it is a mixture. Okay, fine. In the compound, when
Yeah.
they combine, so now they become a new compound, new substance. So they will have a new properties. They don't have the previous properties. Now they have a new property. So it is a compound. But in the mixture, Whatever you have just put, they will show all type of property, because their constituents are made up of so many things.
Right.
So they will show the properties of all these elements, okay?
Mm-hmm.
Because no new compound is going to form in a mixture.
Mm-hmm.
Okay, suppose you have put water, you have put alcohol,
Right.
any random amount, it is a mixture. But if I say calcium carbonate, if I say
Right.
calcium bicarbonate, sodium carbonate, okay, and any other NaHCO3, baking soda, sodium bicarbonate. So all these are the compounds, right? All the formulas like CaCO3, calcium carbonate, calcium bicarbonate or calcium hydrogen carbonate, it is the same meaning. Hydrogen means bi, calcium bicarbonate and the sodium bicarbonate Na2CO3. So all these are considered as a compounds because they are combining in a fixed ratio.
Okay.
Okay, but if I say like usually people drink, okay, like whenever there is a party, so usually people drink like all these alcohol stuff, right? Okay, but some people are adding more water in that alcohol, some people are adding
Distilled.
less. Yeah,
In
some.
distilled.
Yeah, distill and distill is also there. If it is a distill, so obviously they are adding water. If it is non-distill, so they can take directly. Okay,
Pure
so
alcohol.
yeah,
Right.
so water and ethyl alcohol, the ratio is not fixed, na. Some people are adding more
Mm-hmm.
water, some people are adding less water. So it means it is changing, na. And if it is changing, so it is compound or mixture.
Changing its mixture, right?
Yeah, so whatever they are taking the this alcoholic stuff, it is a mixture. Fine.
Yeah, it's not a fixed rate.
Sorry.
Okay.
Okay. So yeah, so yeah, like these are the thing which is the like basic introduction. Now I'm going to the topic, the accuracy and the precision. So what is the meaning
Oh,
of the
I
I guess I told you
okay.
this before.
No, you haven't.
Okay.
But I know what I'm certain about. I'm certain that I know what the definition of both of those are.
Okay. Can you tell me the accuracy? Accurate?
Accuracy is the degree of closeness that
Very good. Closeness.
that
Closeness to what?
closeness that a experiment has to its desired result.
Okay.
Like, okay,
Okay.
let's say we're playing archery, right? So how close is the arrow to the middle, to the bullseye?
Okay. And precision?
Precision is the degree of closeness of the results with each other.
Okay, okay, very fine. Okay, suppose, so can I say that, Vishnu, suppose if I am finding a length of anything, length, the real value of
Oh,
length is 10 centimeter. Okay, okay. So
accuracy is how
yeah,
close
so
the
I took a reading 9.9. So I am accurate or not almost.
accurate. Yes.
If my second reading is 9.8, I am still accurate. If my third reading is 10.1, I am still accurate. If my reading is 10.2, I am still accurate. And my third
Yeah.
reading is 10 only. So I'm very accurate. Okay. So all these five readings are very close to the true value. This is the true
Yes,
value,
and
na?
they're also
Yeah.
very,
So
very close to each
and
other.
these values are lying very close to each other as well.
Exactly, that's
So
precision.
this is the precision. Like your all values are lying very close to each other. So you will
Mm-hmm.
have good precision and you will have good accuracy as well. Okay.
Yeah.
So I guess you know
Yeah.
it already. Okay. So the values lying close to the true value. Okay. How many
Mm-hmm.
values are lying close to the your true value? This is called the accuracy. But all these value which you just took, all these reading which you just took, okay, how close they are with each other. Suppose if I'm saying 9.8, 9.8, and one reading is 4.2, then it is not
Mm-hmm.
precise. It is not precise value. These are the very close. 9.7 are very close, 9.6 is very close. So there is a precision, but there is like this value is not precise, this one, this reading is not precise. Fine. Very
Okay.
simple it
Yep.
is. Okay. So
Mm-hmm.
accuracy and precision, you should. Okay. Now, suppose if there is a bow and arrow game.
Yeah, I was saying about the bow and arrow.
Suppose the middle one is the actual, like obviously we have to target this point, na? The center one. Okay. So your readings are coming actually this, 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 and this. Oh my God. Your all values are lying in the outer circle.
High precision, low accuracy,
Yeah, so it means all the values are lying close to each other. So it means your values are precise. But you are
but not
not,
accurate.
yeah, you are not close to the true value. So it means that you are not, you will not be considered as a accurate. Fine.
Mm-hmm.
Okay. Your all values are like one is this, one is this, one is this, one is this, one is this. It means,
High
yeah,
accuracy, low precision.
low precision, or we can say little precision is there. because
Yeah.
because it is the inner circle na, so values are not so far. Okay, they are almost close to each other. Okay, so we can say that, yeah, it's fine. Okay, now if I talk about the significant figures, so it's the next topic. So the next topic is significant figures, I am just saying. So now,
Like digit, like numbers, like.
yeah, actually, significant figure is the one which has some certainty. We can
Oh.
neglect some certain values, like rounding off. We usually do na rounding off. So, significant figure is the total number of digit in a number, including the last digit whose value is uncertain, or like all the figure which are significant for me. So we have to write only those values which are significant for me, but which are insignificant, which are not so important, I can neglect that na. I can neglect all these things.
Yeah.
So how can we find out? See. Suppose if I'm writing, Vishnu, 5.476.
Mm-hmm.
If I'm writing this 5.476, so just tell me all the values are important for me, right? Because
Mm-hmm.
it is calculating up to 3 digit if your instrument, so it is good thing. So you can't neglect anything. So it means how many values are significant here? How many digits? 4 digit. All four are important, so you will say four significant figures.
What if you
Okay,
have? What if you have a like pi, for example? It never ends.
so yeah, in that case we have to convert the next digit. Now we are taking so many rules right now. Yeah, I'm
Uh,
telling you. Okay, if it is continuously repeating, so we will consider that the next one. If it is the 4, so we will make it 5, and then now it will have a 3 significant figure. Okay, 3.15.
hmm.
So it will have a 3 significant figure only, because then it keeps on infinity. So we can just for our easiness, like 5.72, if I'm saying, just tell me how many significant figure.
Three.
3 significant figure. So it means, or can we say that first rule, all the non-zero digits are the significant one? All non-zero digits, because these are the all non-zero digits. All non-zero digits. Okay. As well as remember, if zeros are lying between the non-zero, they are also significant. All
Yeah.
non-zero digits, as well as zero between non-zero digit, so they are significant. What
Right.
does it mean? Suppose if I am
Five
writing
point zero
5
seven two.
5.074, like this, like 5,
Yeah.
one more,
There's four. Okay. Cool.
5.0745. So how, I mean, what can I say?
Five significant
Yeah, so
digits
this is
or
zero.
figures.
Many people say this zero has no meaning. No, 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 no. This zero has meaning. Zero between non-zero digit, it will be considered as a significant. So that's why it has a 5 significant figure. Okay, got it?
Mm-hmm.
Okay, now just tell me if I'm writing 5.70856. How many?
Six.
Yeah, but you have to take everything and zeros are lying between non-zero. So it is a six significant figure. Very right. Okay. So this is the first rule for finding out the significant figures, right? Okay. Now the second rule is if a zero is present before first non-zero digit, then it will not be significant. Okay.
Okay.
You don't have to consider. Like suppose if I'm saying
Zero
zero
one.
point zero 0.831. So
The
you
first
don't
zero
you
doesn't
yeah,
matter.
you don't have to take this zero and this zero. It has
Okay.
no meaning. So it means how many significant figure you will say? Three
Four.
significant figure. Three.
Oh, three. Oh yeah, three.
This one. Okay. You will not take all these because these zero are front. So if this zero is present before the non-zero digits, so it will be neglected. Suppose if I am saying
Oh,
0.0481, how many significant figure?
three.
Three significant figure. Okay, so this is the second rule. If zeros are present before before
Mhm.
first non-zero digit, non-zero digit, then you will not consider it. Okay, it will not what? It will not be significant figure. Okay, SF means significant figure. You will not consider in your answer. Okay,
Mhm.
okay. Now suppose okay, so this is the second rule. Okay, if I say Vishnu 326.0, so its meaning is it means your calculator is you is can measure one digit after the point as well. Suppose sometime whenever you are buying anything, so it has written now 450.00. Point zero
Mhm.
zero, it means that machine or that they are considering two digit after the point. So it means they are showing you the how accurate and precise value they want to give you after the point. So it is considered. Okay, after the like last zeros are considerable if it is right after the point. Okay, so it means this one, this one, this one, and this one all are the significant. Okay,
Okay.
see Vishnu, if I am saying 25, so I have two significant figure. But if I say 25.00, it you will say sir it has the same meaning. But actually when I write point zero zero, no, it means I am taking care of two digit after the point. It means if you
Mhm.
have if you have taken if you have taken 25 rupees point 50 from me, so I will take care of this point 50 as well. I will not say no, no, just give me 25 only. No, 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 no. I will say give me my complete amount, 25.50. Okay. So when you are considering these two digits after the point, it is considerable. Okay.
Mhm.
So if zero is present after the after non-zero non-zero digit and to the right side of the decimal, because it is right side of decimal, then it is significant figure. Then it is significant figure. Okay. Okay, Vishnu. If I'm saying 567.00, how many significant figure?
Five.
Yes, because you will consider. So these rules you have to always remember. How many?
Three.
Three. Okay, this is five. So very simple, fine. Okay, actually significant figure rule sometimes fails. Okay, so rule 4 is very important, which you need to take care of. Okay, if a zero is present after the non-zero digit and there is no decimal, so if there is no decimal, so it may be considered or it may not be, depending in what way you have just write your answer. See, Vishnu, Do you know the scientific notation? We can
Yeah.
represent every value in a scientific way. Okay, suppose if I am saying 3.2 into 10 raised to power 3. So we will never consider that 10 raised to power 3. In the significant figure, we don't consider 10 raised to power 3. So only this one and this one will be considered. It will
So
become
it's two.
two significant figure. But
Okay.
you can play a game here. Cleverness. We can also write this na
3.2.
3.20 and into 10 ki power, like no 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 no, one second, one second. We can write this see, I haven't changed the point. I haven't changed
Yeah.
the point. I have just put the extra zero. So it is still 10 raised to power 3. So, but
Oh yeah.
now, according to rule, now it
Three.
will, yeah, it will become the three significant figure. Okay. So, this is the thing which you need to take care of. Okay. Fine.
Mm,
Suppose
yeah.
if I'm writing 5.67 and into 10 raised to power 4. So, it has a how many significant figure?
Three.
3. But if I'm writing 5.670 into 10 raised to power 4, it will become four significant figure. Okay, so it means we can just simply change the things. Okay, now, suppose if I am writing it as 5 no 56.7 into 10 raised to power 3. Okay, we can write as well na.
Mm-hmm.
So now when you are changing the power, still it has how many significant figure? Still, Vishnu?
It's three.
Three only, yes. Only you don't have to take care. You have to just don't consider that thing which is in the
Yeah.
10 raised to power. And whatever you just see in the front, you have to consider. That's it.
Yeah.
Okay.
Simple.
So it may be or may not be significant. In this case, it's little flexible. So if zero, I'm writing here, if zero is present after non-zero digit, but decimal is absent.
Mm-hmm.
Decimal is absent. Then, then this zero may or may not be significant. May not be significant. Depends, like you have wrote it, you have write it or not, depending upon the scientific or the exponential notation. In which form you have just written there. So it depends completely on that. Okay, see
Yeah.
Vishnu. Okay, suppose if I am writing a value like this 56800,
Yeah.
how many significant figure it has?
Five.
5, right? Because I have written in such a way. But suppose if I write this in that way, 5.68 into 10 raised to power 4. So now
Two.
how?
Or
2.
three. Three. Three.
3
Sorry.
significant. It means it is completely depending on our notation na, in which way I am writing my like digits. It is depending on me only na.
Mm-hmm.
Okay. So this is all about your significant figure. Any single doubt here?
Nope.
Okay. And remember, you can add after the point. If one student was there and he asked one question to me, sir, zero after the point, it is significant. I said yes. So he said, sir, just tell me how many significant figure it has. I said one significant figure. Okay. Then he said, sir, 5.00, how many significant? I said 3 because 00 after
It's the
point is
same number.
significant. Yeah. But and then he said, sir, what if I say 5.00000000 infinite? Eh? Then I said, then obviously infinite significant figure, na? Because we have to follow the rules. Zero
Yeah.
after the point it is significant. So if you are taking it to the infinite, so obviously my significant figure is also going infinite. Very simple. If any exact number is present and if we can add the infinite number of zeros after the decimal point, then obviously it contains the infinite number of significant figures. Okay, whatever the zeros you have after the point, you have to consider that into the significant figure. Fine.
Yeah.
And you don't have to take the like centimeters, meters. You don't have to take care about the units. You just have to take care about the values. Okay, like suppose if I say 5 centimeter and if I say 500 meter, suppose if I say like that. Okay, or if I, so if I'm, okay, if I say 500 centimeter, okay, and if I say 5 meter, something like that. So obviously it has a three significant figure, it has only one significant figure. Okay, so it completely depends on you in which way you are writing. Okay,
Okay.
the meaning can be same, but your significant value will be reduced. Got it?
Yep.
Okay. So, okay, and remember, whenever you are solving any type of question, na, so the least significant figure, if you see, so in your answer, you have to write your answer in that least significant figure as well. See what I'm saying? If you are adding three digits, okay, so just see which have a minimum significant figure, okay, and then your answer should be in that significant figure as well. Suppose if I'm saying 4.732, if I have a 2.11, and if I have a 3.08. Okay, 3.08. So just tell me which how many minimum significant figure are there? Vishnu, can
For
we
this
say
number.
it has a four significant figure?
Yeah.
It has a three, and it also has a three. So
So
which is the
minimum is 4.
minimum is four? Don't you
Oh,
think it is maximum? Four and
oh
three, which
yeah,
is
but the
minimum, which is
maximum is
maximum? Yeah. So minimum is three, na?
maximum is
Maximum
yeah.
is four, minimum is three. So it means your answer should also be in three significant figure. Okay. You don't have to
Oh,
write. Okay. So firstly, just solve it. If I solve it, it is 2, 3 plus 1 and 8. It will become
2,
12. 12 will become 1, 8, 1, and it will become the
9,
9. And it will 4, 2, 3. It will become 9. So it,
10.
it, it
Oh
has a
yeah.
total four significant figure, na? Four, but
We have to
according to,
neglect it too.
yeah, we have to neglect the last two, so the answer would be
Oh,
9.92. Okay, because
okay.
I because there is a rule. The least precise term you have to take, the least significant figure you have to take in your answer as well. Got it? Tell me, Vishnu.
Nothing. Sorry. Yep.
Okay. So Vishnu, if I'm saying suppose 4.318, 3.41, and if I write 2.1,
Hmm.
can you just tell me? You have to add.
Mm-hmm. Have to add. Okay. So 8.
8.
Last
But significant
last
figures are
digit's
2.
8.
But
No,
significant figures are,
okay. Could I just do it on paper?
yeah,
8,
yeah.
2, 8. Okay, 9.8.
9.8. Yes. It is 8. It is 11234. Okay, 7 and 8.4,
9.
3 and become 9. But I know that it has a 4 significant, it has a 3, it has a 2. So I have to take two significant figure in answer, right? So in my
Mm-hmm.
answer, I will consider only first to 9.8. I will not take to 8. Okay. Got it?
Yeah. Mm-hmm.
Okay. So this is how we have to solve the significant figure. Okay. This topic is quite important for the entrance point of view. Okay. So now we are just finishing it here. Significant. Now because it is the introduction actually, Vishnu, it is your first class, na? So that's why in the chemistry it is the introduction. Before we start the main chemistry, you should know the basic things. Now, if I talk about unit, so Vishnu, you should know we have total 7 fundamental units. I guess you have studied that. 7 fundamental unit, and from the 7 fundamental unit, we have just derived so many units from these 7 fundamental one. Okay, so we have the
Mm-hmm.
7 fundamental units. Okay, and from these 7 fundamental units, we have just derived so many one. So now, obviously, the first fundamental unit is the, okay, so from the fundamental one we can just derive so many units now. So first is what? It is mass. And like in which unit we have to consider the mass, you know it very well. In which unit we have to consider the mass? It is the kilogram. You know it.
Okay. Yeah.
Kilogram.
Kilogram.
Okay, so
Yeah.
the first fundamental unit, it is the mass, and it is measured in kg. And you know it, mass, like mass is constant for everybody, na? We all have a like mass, and it remain the same in every planet. The weight get changed, but mass remain the same. Second unit, it is the length, and we usually measure the length in which form? In meter, right?
Okay.
So meter length. The third one, it is the temperature. So
Mm-hmm.
in which unit we will measure the temperature?
Celsius.
Celsius. Are you
Oh,
sure?
Kelvin. Yeah.
Yeah, in the chemistry, in calculation, we always take Kelvin. Okay, Celsius is used
Okay.
in India mostly. Okay, but in the calculation work, we always take Kelvin. Time,
Okay.
seconds.
Sec.
If I talk about current, electric current in the in the physics, you have studied that. So current is measured in
Mm-hmm.
ampere,
Yeah.
ampere
Okay.
scientist
Yeah.
name. And the amount of substance in the chemistry, amount.
Density.
No, 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 no. Density, no. Density खुद एक वो है. Density is itself a term, itself a unit. I mean itself a
Oh.
quantity. Amount of substance is measured in mole. Okay,
Oh.
like 5 mole of sodium, 10 moles of lithium. Okay, something like that. And the last, which is the luminous intensity, like from the light. Light is falling on my face, light is falling on your face, that is a luminous intensity. And it is basically like the scientists work on this, and it's like his name is Candela. Luminous intensity, and its unit is Candela.
Mm-hmm.
Okay, so we have total like 7 fundamental units. And yeah, and whatever the units we will take out, we will derive from all these. So these will be considered as a derived units. These are the fundamental one, all 7. And if by using all these, if we are making other units, then it will be considered as a derived units.
Okay.
Okay, derived
Yeah.
units. Okay, I guess it is completely clear to you. Okay,
Mhm.
wait a second. Some people are saying, sir, wait a second. Like, sir, gravity. So gravity is made up of the, obviously, you know that, like
Acceleration.
length and the time. Okay, gravity unit. So it means
Time. Yeah.
gravity is a drive, na? It is all coming from all these are the fundamental one. And from the fundamental we can drive so many things, so many derived, like velocity. Velocity
An
means
acceleration.
displacement upon time. Displacement
Yes.
means length, time means second. So again, it is coming from the fundamental. Okay. So whatever things are coming from the fundamental, these are considered as a derived units. Okay.
Right.
So these are the seven fundamental one, and you have to remember the units as well. Okay. And see Vishnu, now we are moving to the main portion of chemistry. Okay. So calculation is also a very important one. Okay. So you should know, if I say 10 raised to power minus 1, it means I'm dividing by 10. 10 raised to minus 1. So it is known as a decimeter, deci. Okay. If I say 10 raised to power minus 2, so obviously you know it's centi. Okay. If I say 10 raised to power minus 3, then you will call it as a milli.
Yeah.
If I say 10 raised to power minus 6, it is micro. It is widely used. Micro, very small units.
Nano.
If I say, yeah, 9 is nano, and 10, I guess you have heard angstrom.
Nope.
Angstrom. Okay. So angstrom is there, and it is represented as a naught. A naught means 10 raised to power
Oh.
minus 10. Okay. If
How
I
about
say,
Pico? Pike.
yeah, yeah, pico. We usually say pico. Okay. So 10 raised to power minus 12, it is pico. And the last 10 raised to power 80, like 15, 15, 15, it is the very, very small for measuring the like atoms and electron nucleus. It is a femto.
Femto.
Femto, yes. 10 minus 15, so it is femto. Okay.
Negative.
So these are measuring the small thing, right? Micro. But if I say macro, like badi cheeze, very large things. So obviously, I guess you know it. 10 raised to power 3, it is a kilo.
Yeah.
Okay. If I say 10 raised to power 6, it is mega, kilo, mega,
So
giga. 10 raised
Giga
to power
Terra.
9, it is giga.
12 is
10
Terra, right?
tera, yes, tera. And
Peta. I don't
15 is peta.
Hmm.
Okay. So these are measuring the large things. These are measuring the small things. Okay. Got it?
Yep.
Okay. So these are the like subsidiary units, and you have to remember for maze, because in the calculation, definitely you will see all this thing in your numerical path. Okay. Now we are moving to the like main chemistry. I'm just coming. Oh, obviously, you know that law of chemical like combinations. So I guess you have heard about law of conservation of mass. What is the meaning of law of conservation of mass, Vishnu?
Mass can never be created or destroyed.
Yes, so in a chemical reaction, whatever the mass you have at the reactant side, so obviously you have the like equal mass at the product side. Okay, nothing is going to be lost. Okay. So if I have the ice here, so ice has a suppose 100 gram. So if it is converting into the liquid, okay, if it is melting by giving the heat, so it will become the water. So how much amount of water you will get? 100 gram only, because mass can neither be created nor be destroyed.
Hmm.
Mass at reactant side should be should be equal to the product side. One second, just should be equal to the product side. Fine.
Yeah.
Okay. So if I say I have a calcium carbonate and it is giving you CaO plus CO2. Are you sure like it is following the law of conservation of mass? Are you sure?
Yeah, it always does. It has to.
Okay. Let me check that. Calcium mass is 40, carbon mass is 12, and 3 oxygen are there. So I have to write 3 into 16. 3 into 16 means 16 3s are 48. 48 plus 12, 60. 60 plus 40, it will become 100. Total 100 gram. Now calcium is 40. 40 plus 1 oxygen, so it will become 56 total, plus CO2. Carbon is 12, oxygen is 32. 32 plus 12, it will become 44. So is it matching? 56 plus 44, it is becoming 100. So it means law of conservation of mass is followed or not? Tell me. Obviously, so mass will remain the same. It is the law of conservation of mass. But Vishnu, there is a drawback. Law of conservation of mass doesn't follow in a particular situation. What kind of reaction it is?
Chemical reaction.
Chemical reaction. But all these are the chemical reaction. In which condition your law of conservation of mass is not followed? एक ऐसी condition है जहाँ पे law of conservation of mass follow नहीं होता है. Did you
What
understand what I just said?
energy is released?
Okay. And in which reactions energy is released?
Exothermic?
Exothermic. But every exothermic.
Exergonic.
Okay. I'm telling you, Vishnu.
Is it
Actually,
endergonic or exergonic?
nuclear reaction.
Oh, okay.
Whenever, because nuclear reaction is completely exploding, na?
Yeah.
Exploding continuously. Hiroshima, Nagasaki,
Nagasaki.
Nagasaki. Okay.
Nagasaki.
Okay. So yes, so it means if there is a like a nuclear bomb, okay, so it will not follow the law of conservation of mass. Initial mass
Right.
was less, but the final after bomb blast is quite large. So in the nuclear reaction, it is drawback. So you can't apply your law of conservation of mass in nuclear reaction. You have heard now
Mhm.
nuclear fission, nuclear fusion.
Yeah.
Okay, we will discuss it as well. Nuclear reactions. Okay, and the last law
Hmm.
which I want to cover as well here, law of constant proportion. So law of constant proportion means whenever you are making the compound, so obviously they are combining in a fixed ratio, na simple ratio. Constant proportion bolo ya law of constant composition bolo. Whenever you have, whenever you are making compounds like CO2, so they will have a simple mass. What is the mass of carbon? 12. What is the mass of oxygen? So it is 2 into 16. It is 32 na. So
Yeah.
what is the simple ratio? 4 3 ja 12 and 4 8 ja. So it is a simple ratio 3 ratio 8. So this is a constant
Yeah.
composition. Same thing if I say H2O. So it is 2 ratio 16. So what is the simple ratio you will get? 1 ratio 8. Okay. So this is the law of constant. So whenever a compound is formed, so they are combining by when a fixed mass ratio. Okay. So when compounds are formed by combining elements or atoms in
Mhm.
a fixed ratio by mass.
Yeah.
Fixed ratio by mass. Okay. So
Yeah.
all compounds have the fixed ratio of the mass. So now Vishnu, if I say, can you just tell me for the, I mean the fixed ratio, 1 second just. CO2 is H2 is there. Okay. One compound I want to take. 1 second. Mm, if I have a compound, okay, let's take for the calcium carbonate. Yeah, it has a 3 ratio, like point something. So what is the mass? What is the ratio? Or you can also take like calcium oxide. Firstly, tell me about the calcium oxide. Can we see
Okay.
calcium
So
is, calcium is
20
40
to 6.
and
Yeah.
oxygen is 16. So when you cut it,
Yeah.
you will get 20:8. Again, you
Which
can
is
cut it
4, 5,
10:4. And again, you will get
5 rate.
5:2, right? So this is
Yeah.
your simple ratio by mass. Same thing I can do here, 40
40
ratio
to
12
12.
ratio 48,
6. Okay.
right? So when you cut it, 26 and it will become
24.
24. Again, 10 ratio 3
3.
ratio 12.
12.
Uh, can I cut it more? No,
No.
no. So this is the simple ratio, 10 ratio 3 ratio 12. This is the ratio for the calcium carbonate, right? So this is the law of
Mhm.
constant proportion or law of constant composition. Fine. So this is about
Right.
the law of constant. So this is the basic introduction about the chemistry, Vishnu. Okay. So in the next class, we will start our
Mhm.
mole concept. Okay. So this is the beginning of
Mhm.
this chapter. Okay. So we'll meet you in the next class. That's all for the today. Okay. See you. Bye bye and have fun.
Bye.
Bye bye.
All right. Bye.